Welcome to the deep dive. This is where we take those huge stacks of, really dense technical docs and strategic plans, and we boil them down. We get to the core knowledge you actually need for your biggest professional hurdles. And today, the stakes, they're pretty high. We are diving deep, really deep into the deployment lifecycle part of the Agentforce Specialist certification. So if your mission, your absolute goal, is to pass this exam, and it's tricky, let's be honest, on your first try. If you need to cut through all that noise, that information overload, just focus on what you need to know for deployment, well, you're in exactly the right place. We've pulled it all together. DevOps strategy guides, deep dives into the technical metadata, and even the kind of practice questions you're likely going to see. Think of this deep dive as your shortcut, your path to really mastering Agentforce metadata, the deployment best practices for these new AI bits, and navigating those crucial data cloud components for grounding. Okay, so let's unpack this. Agentforce isn't just some small project. It's a massive strategic move for Salesforce. Yeah, our sources are clear on this. The priority is enormous.
They talk about Salesforce hiring, 2,000 people just to sell Agentforce.
Yeah.
Now, that kind of investment, it doesn't just mean market buzz. It means serious technical pressure. We're not just figuring out how to deploy one agent. We're figuring out how to roll out, maintain, and govern a system that's critical to the company's whole future, which means basically zero tolerance for deployment screw-ups.
And it's fascinating, right? Because that high-stakes business environment you just laid out, it translates directly, one-to-one, into the technical rigor you need for deployment. Agentforce is Salesforce's AI framework. It's designed fundamentally to empower organizations, streamline workflows. But the catch is under the hood. And this is the absolute key for anyone serious about the certification. It relies entirely on disciplined metadata management and robust DevOps, specifically tailored DevOps, because you have to handle the uniqueness and the interdependencies of these Agentforce metadata types. If your deployment process is messy, your AI, it's just not going to be reliable. Simple as that.
Okay, so let's set the stage. The context the exam assumes you get. The strategic why behind Agentforce. It's not just AI for AI's sake. It's about leveraging the platform's existing strengths, right? Customization, speed.
Exactly. Agentforce is built to fully leverage that core Salesforce metadata-driven architecture. That's what gives it the agility, the customization that maybe, pure third-party LLM solutions might lack. And the benefits, which are driving all this adoption and therefore the deployment complexity, they're pretty clear. First, you've got boosting efficiency, automating those routine high-volume tasks that just burn agent time. Second, delivering a really superior customer experience. We're talking personalized, data-grounded interactions. And third, enabling organizational agility. So the business can respond fast to shifts in customer needs or market trends just by updating the agent's behavior quickly.
But there's always a catch, isn't there? And the catch here, the reason this deployment lifecycle stuff is so critical, is that making that agility happen means adopting totally new metadata types. And these have to be governed just like any other production code. If your metadata management is weak, your AI agents, they get inconsistent, they become a liability across environments, frankly.
Precisely. You absolutely need robust, reliable DevOps processes. Think of the Agentforce agent as a complex piece of software. It's built right on top of your CRM data model. You have to treat it with the same rigor you'd apply to, say, complex Apex code or those big, sprawling flow deployments.
Okay, before we dive into the heavy DevOps steps, let's quickly cover the building blocks. The sources talk about 3 main low-code tools used to actually construct these agents. What are they, and what's the specific job of each one?
Yeah, the creation phase is designed to be low-code, which is great for accessibility. But crucially, the outputs of these tools, that's all deployable metadata. So first up, you have the agent builder. Think of this as your main canvas, your control center. It's the core admin tool where you define the agent's high-level purpose, its job to be done, as they say. You specify the logical topics it can handle, like order status or password reset, and critically, you define the pre-built actions it can take. These actions might call standard Salesforce stuff like flows or maybe external APIs or even specialized prompts in Apex. It basically orchestrates the steps.
Okay, so Agent Builder handles the scope, the capabilities, the orchestration. Where does the actual sort of specialized AI smarts come in?
That's where the model builder steps in. This tool is all about beefing up the agent's intelligence engine. It lets organizations do a couple of key things. One, they can bring in their own custom AI models, maybe trained on proprietary data. Or two, they can integrate external third-party large language models, LLMs, through secure connections. The metadata deployed from here. It manages activating those models and configuring them for use across the platform, especially when you start using the prompt builder.
Gotcha. And finally, the output, how the agent actually talks or refines what it says.
Right, that's the job of the prompt builder. This one is absolutely essential for refining the output, personalizing it, and importantly, ensuring the safety and appropriateness of what the agent generates. It lets you create these reusable prompt templates. And the key is they're inherently tied to your CRM data or your data cloud data.
Yep.
These generative templates can then be embedded directly into workflows. Like a classic example is using a field generation template to dynamically populate a field. It ensures the agent's language is consistent, it's on brand, and it's grounded in real-time customer facts. #TAG2. The 6 key steps to a successful Agentforce DevOps strategy.
Right. We know what we're building now. Let's get into the deployment framework itself.
Yeah.
The sources lay out these 6 essential steps, kind of sequential, for rolling out Agentforce components. And this framework seems vital because it shifts the mindset, right? It's not about one big deployment. It's about continuous iterative AI ops.
That's exactly right. The whole philosophy is treat these AI agents like sophisticated software products. They need CI/CD rigor. And let's start where, honestly, most failures probably originate. Step 1, plan with purpose. This just cannot be an afterthought. You can't skip this.
Okay, so if you do the planning right, what specific actionable things does a DevOps team absolutely have to address before they even touch a sandbox config? Let's get specific here.
Okay, 5 critical things need definition in this planning phase. First, stakeholder alignment. And this is more than just, a kickoff call. It means getting technical sign-off from your governance teams, from leadership, and crucially, from the end users, the human agents. You have to make sure the AI strategy ties directly to measurable business outcomes. Everyone needs to be on board. Second, process mapping. You've got to meticulously document the current workflows, whether they're manual or semi-automated. Why? To pinpoint exactly where Agentforce can deliver the maximum ROI. Identify those automation sweet spots with the highest impact and lowest risk. Third, and this one's huge, data readiness review. Since the agent relies so heavily on data grounding, you have to review your data models, your data lineage, your governance policies. You need to ensure that Agentforce components, whether it's for case routing or pulling knowledge articles, integrate cleanly and reliably. Because if your data is garbage, your AI's output will be too. Biased, inaccurate, useless.
Okay, stakeholder alignment, process mapping, data readiness. What about the risks? The risks of bringing this big new system into a complex enterprise setup.
Right. 2 more critical elements address that directly. Fourth is change impact analysis, and this one gets skipped way too often. You have to meticulously assess how these new specialized metadata types, the planners, the functions, the prompts, how they're going to affect your existing automations, your org performance, the whole architecture. You need eyes wide open about downstream risks. And fifth, absolutely crucial, compliance and security checks. This means digging into how Agentforce features align with your internal policies, data residency rules, industry regulations like IPAY or PCI. If you're in a regulated industry, this is completely non-negotiable.
Okay, moving on. Step 2, metadata mastery. You called this the intellectual foundation earlier. This feels like where we stop treating AI like some kind of magic box and start seeing it as structured, deployable configuration.
Exactly, because Agentforce is fundamentally metadata-driven. Success demands that your entire deployment team, devs, release managers, everyone truly grasps these specialized Agentforce metadata types. And it's not just knowing the names, like Genia Planner, they have to understand the strict dependency structure. For instance, knowing that a Genia function depends on a specific Genia prompt template prevents, I'd say, the most common deployment failures right there.
Which logically leads to step 3, automate to innovate. Our sources mentioned something like a 45% reduction in release cycle time for companies using CI/CD for metadata.
Yeah.
How do we get that kind of efficiency with these new GenAI bits?
Yeah, that's a significant number, and it comes from eliminating manual steps and enforcing consistency. Automation is really the heart of speed and accuracy here. Your Agentforce components must integrate seamlessly into your existing CI/CD pipelines. Tools like Cert or Capado are pretty much essential because they've been specifically updated. They recognize, filter, and handle the deployment ordering of these GenAI metadata types correctly. This includes automated dependency checks, running unit tests, deployment validation, all the things that dramatically cut down on the human error you get with complex, dependency-heavy manual deployments.
All right, step 4. Feels mandatory when dealing with LLMs. Test early, test often. And this sounds like it needs to go way beyond just typical Apex unit tests.
Oh, absolutely. Because AI involves so much nuance, continuous testing has to cover, let's say, 3 main dimensions. You still need your standard unit test. Does the Apex code or the flow run correctly? And your integration tests, do the different systems talk to each other properly? But then you need specialized testing for the agent itself. User acceptance testing, UAT, becomes absolutely paramount. This means real human agents interacting with the AI in a safe sandbox, validating the generated output, checking for factual accuracy, making sure the tone or persona is right. Since Agentforce metadata interactions are so nuanced, you have to test in every environment. You're guaranteeing not just functional correctness, but also the quality and safety of the AI's output.
Next up, robust version control. Creating that golden source, ensuring integrity. This sounds like standard DevOps best practice, but maybe even more critical here.
It is standard, but the stakes are higher, maybe. Version control has to be the single source of truth. Forget relying on the production org configuration. Teams must maintain clear, consistent tracking of all metadata changes in a version control system, or VCS usually Git. Why? Well, it allows for easy, auditable rollbacks if a deployment goes sideways. And it provides that historical audit trail that's often required for compliance, especially in regulated sectors. This really necessitates a clear, rigorous branching strategy, something like Git flow, to keep feature development isolated and minimize those painful merge conflicts.
And finally, step 6, embrace observability and continuous improvement. Deployment isn't the finish line, is it?
Not at all. It's really just the starting line of an ongoing refinement cycle. You have to build robust observability into the whole process. This means actively monitoring your deployment success rates, deployment times. Monitoring org health is the agent impacting performance. And critically, monitoring Agentforce usage metrics, user satisfaction, resolution rates, deflection rates. Is it actually working? All that data you collect. It must feed back into refining your DevOps processes through regular retrospectives. It's that ability to learn fast and iterate that turns a successful deployment into a successful, high-performing AI program.
Okay, we've covered the strategy of the process. Now we get really technical. This feels like the absolute core for the exam, the metadata specifics and that critical hierarchy. You said if you mess up the deployment order, you're guaranteed to fail the migration.
Yeah, that's not an exaggeration. What's fascinating and kind of crucial to internalize is that Agentforce metadata is literally the DNA, the source code of your generative AI agents. It dictates the agent's understanding of intent, its orchestration logic, every single integration point. Managing this DNA systematically, that's what gives you consistency, reliability, and speed across your environments.
Okay, sources say metadata API version 60 or higher is a must. Let's break down those 5 core Agentforce metadata components that, you absolutely have to know for the exam.
Let's do it. These 5 types define the agent's structure, logic, and its connection to the outside world. First, you have bot version. This is your top-level container. It defines the overall Agentforce agent, or maybe an older Einstein bot. It includes its activation status, the channels it uses, and critically, which specific version is live right now. Second, GenAPrompt template. These are those reusable structured templates we mentioned. They tell the LLM how to generate specific kinds of output, ensuring brand voice, injecting context variables safely, super important for consistency. Third, GenA function. Think of this as an agent action. It defines a single specific thing the agent can do, like query an external system via API, run a flow, maybe update a record. Crucially, it defines the context variables it needs to run, like a customer ID or case number, and it links to the necessary prompt templates for generating its response or asking clarifying questions. Fourth, GenAI plugin. This acts as a logical grouping, a topic. It defines a domain of capability, like order management or account information. It groups together all the related GenAI function actions under that topic. This helps the planner figure out which tools are relevant for a user's request. And fifth, GenA Planner, or more recently, GenA Planner Bundle. This is the brain, the reasoning engine, the orchestrator. It takes the user's potentially complex intent, breaks it down into smaller subtasks, and then sequences the calls to the right functions and plugins to get the job done.
Let's pause on that planner for a sec. Sources mention this shift from the single GenA Planner to the newer GenA Planner Bundle in API v64+. Why did they do that? What's the benefit for someone managing deployments?
Yeah, this is definitely specialist level detail. Good catch. The older GenA Planner was, well, monolithic. One big chunk of XML defining all the logic. If you needed to change just one small part of the planning sequence, you had to redeploy the entire thing. That increased the risk of accidentally breaking something else and made merge conflicts and version control a nightmare. The shift to GenA Planner Bundle in v64+ introduces modularity. It breaks the orchestration logic down into smaller, more manageable components or bundles. This is a massive win for DevOps. It means you can deploy specific, isolated updates to the planning logic without touching the rest of the agent. It drastically reduces deployment risk and speeds up how fast you can release new capabilities.
Okay, that modularity makes the dependency structure even more critical then. Since these components are all linked, what is the exact, absolutely strict deployment order you have to follow to avoid those catastrophic failures?
You have to burn this rule into your brain. Dependencies must exist before they are referenced. So, step 0. Get your auxiliary artifacts in place first. Deploy all the prerequisites. That means your Apex classes, your flows, any external service registrations, custom metadata types, custom object schemas, anything the agent's actions rely on. If an action needs a custom field, that field must be deployed and available first. Then, the Agentforce specific order is 1. Deploy the bot version object itself, especially if it's a brand new agent or you're setting up a new version structure. 2. Deploy the Gina prompt template objects. Why? Because functions in the planner reference these templates to generate output. They have to be there first. 3. Deploy the Gina function objects, the agent actions. This is a critical checkpoint. The function metadata needs to successfully resolve all its references, context variables, the prop templates it calls. If a reference template is missing in the target org, this deployment step fails. Hard stop. 4. Deploy the Gini plugin objects, the topics. These plugins group the functions. So logically, they have to be deployed after the functions they contain have been successfully migrated. 5. And finally, the last piece. Deploy the Gini planner bundle, or the older Gini planner. This is the final orchestration logic, and it's often the most common failure point. The planner defines the agent's overall behavior based on all the referenced plugins and functions. If even one referenced topic or function doesn't already exist and isn't active in the target org, the deployment of the planner will fail. You'll get a dependency resolution error, plain and simple.
Okay, crystal clear. So if I'm prepping a deployment package or script, I need to make absolutely sure my Gena function components are processed before my Gena plugin components, and both of those are done before the Gena planner bundle.
Exactly. That's the sequence. And once all that metadata is successfully in place in the target org, the very final step is usually activating the new configuration, often by switching over to the newly deployed bot version in the production environment setup.
You mentioned common pitfalls earlier. Beyond just missing dependencies or getting the order wrong, what's a real-world gotcha you've seen trip up a team, even if they thought they had the sequence right?
Oh, a painful one is environment mismatch. Happens all the time. Teams, maybe in a hurry, hardcode org-specific IDs like a specific flow version ID or a record type ID directly into their Agentforce metadata XML in the sandbox. Then they deploy to production and crash, because those hard-coded IDs simply don't exist or are different in the target environment. You absolutely must rely on dynamic referencing, usually using unique developer names for flows, Apex classes, etc., and avoid hard-coding specific Salesforce IDs at all costs. And the other big pitfall, we touched on it, but it bears repeating, the manual toggle frustration. Remember, Agentforce builds on the Einstein platform. Certain core platform features like enabling Einstein bots globally or turning on Einstein Copilot itself often cannot be enabled purely via the metadata API. So you might perfectly script and deploy all your functions, planners, everything, only to find the agent doesn't work because someone forgot to flick the master switch in setup. Checking those manual prerequisites is often the difference between a smooth release and a late-night scramble. Hashtag TAG30V, deployment tools and strategies, how it gets to production.
All right, we know the dependencies. We know the critical order. The next big question is, how do we actually move this stuff safely and reliably? It's good news, I guess, that the standard Salesforce deployment tools support this new metadata.
Yes, they do, which definitely helps streamline setting up your pipelines. For migrating the components, you've got the standard options. You can use change sets. Admins often like them for smaller, simpler configuration moves, but let's be honest, they lack the robust scripting capabilities, dependency management, and easy rollback safety you get with more advanced tools, especially for something this complex. Or, and this is generally the recommended approach for anything serious, you use the Salesforce CLI metadata API. This gives you a complete, auditable, and scriptable way to migrate everything the Agentforce components, plus all their dependencies like flows and Apex code. It ensures a much more reliable and repeatable process.
And for teams already using more sophisticated CI/CD pipelines, how have the big DevOps platforms adapted to handle this Gen AI stuff?
Yeah, the major DevOps platforms like Capado and GearSet are really essential here. They've specifically built in logic and filtering mechanisms to understand these specialized Agentforce metadata types. So when you configure your CI/CD pipeline in those tools, they can automatically enforce the current deployment ordering we just hammered home prompts before functions, functions before planners. And importantly, they integrate robust rollback safety. If your post-deployment UAT fails, you can quickly and cleanly revert the agent configuration back to the last known good state. That's huge for production stability.
Okay, before hitting deploy on that pipeline, we need a checklist for the target environment, right? What are the absolute must-have prerequisites in the production org before we even attempt to push the Agentforce metadata?
Yep, 3 non-negotiable checks before you deploy. 1, API version. Double-check the target org is running metadata API version 60 or ideally higher, especially if you're using planner bundles v64+. 2, licensing and permissions. Confirm all the necessary licenses are provisioned Agentforce, Einstein bots, Data Cloud if you're using grounding, and critically make sure the dedicated agent user profile or permission set has the correct system permissions and object access needed to function. 3, configuration toggles. This is that manual step again. Ensure the specific Einstein bot and agent features are actually enabled in the setup menu of the target org before you run the deployment. Don't let that forgotten toggle bite you.
Got it. And finally, let's just nail down the versioning best practice. When you've developed and tested a new improved agent version in UAT, what's the safest flow to get it into production?
The recommended best practice is definitely sequential and emphasizes safety and minimizing disruption. 1. First, in your sandbox, like UAT, you create and thoroughly configure the new agent version. Get it working perfectly there. 2. Now, when moving to the destination org, staging or production, you often need to first clone the existing live agent version. This creates the container, the new version object structure, in the target org. It ensures the source and destination bot version objects match structurally before you deploy changes into it. 3. Next, you deploy the actual new Agentforce metadata components, the updated prompts, functions, plan a bundle targeting that newly cloned version object. 4. Finally, you validate the deployment thoroughly in the target environment, ideally staging first. Once everyone's happy, you then activate or switch over the live bot version pointer in production to use the new version you just deployed. This staged approach minimizes risk and potential downtime.
Okay, makes sense. But agents, especially AI agents, are really only as good as the data they can access, right? So we need to shift gears a bit and talk about the data cloud side of this deployment picture. Specifically, how Agentforce gets that accurate grounding.
Absolutely. The core concept you need to understand here is grounding. Agentforce heavily relies on a technique called Retriever Augmented Generation, or RAG. The whole point of RAG is to make sure the AI's responses aren't just hallucinated or based purely on its generic training data. Instead, they need to be precise, factual, and based on your structured, reliable, verified data from your CRM, from Data Cloud, from your knowledge base. So instead of the LLM just making something up, the RAG process first retrieves relevant pieces of your proprietary information, and then it grounds the final response in that specific context. And this whole RAG process, it's managed primarily through the Agentforce data library feature within Data Cloud.
Right. So when an admin sets up one of these Agentforce data libraries, maybe they point it at Service Cloud case data, or maybe they ingest a bunch of product manual PDFs, the exam is going to expect you to know what happens automatically behind the scenes in Data Cloud. What are the 3 essential components that get automatically created the moment you configure and save that data library?
Yeah, this is a classic exam point, definitely high-yield knowledge. When you set up and save that Agentforce data library, Data Cloud instantly, automatically spins up 3 critical linked components needed for RAG1. A data stream. Think of this as the secure pipeline. It's responsible for ingesting the data from your chosen source, whether that's real-time record changes or scheduled ingestion of documents. 2. A search index. This is the organized structure where the ingested data actually gets indexed. It determines exactly which fields and which pieces or chunks of data are available for the AI to search and retrieve later. It's the catalog 3. And a retriever. This is the smart search mechanism itself, powered by AI. It takes a user's query, uses the search index to find the most semantically relevant data chunks based on meaning, not just keywords, and then delivers that specific relevant data back to the LLM to use for grounding its final answer.
Okay, so the data stream pipes it in, the search index organizes it like a library catalog, and the retriever is the smart librarian that fetches the right books. But the data itself, especially from unstructured sources like PDFs, isn't just raw text when it gets searched, is it? It needs some prep work. What's the precise 4-step process the sources describe for preparing raw text for this kind of AI-powered semantic search?
Right, that preparation is crucial for making sure the RAG process is fast and accurate. It optimizes the data for meaning-based retrieval. The 4 steps are: 1, loading. First, you just get the raw, unstructured text like documents, website articles, transcripts into the Data Cloud environment. 2, chunking. This is super important. Long documents or articles need to be broken down into smaller, semantically coherent parts or chunks. Why? Because searching against these smaller, focused chunks dramatically improves the relevance and accuracy of what the AI retrieves. It can pinpoint information better. 3. Vectorization. Now, this is the AI magic bit. The text chunks are converted into numerical representations called vector embeddings. For a specialist audience, think of this as mapping each chunk to a point in a high-dimensional mathematical space where chunks with similar meaning are located close together. This enables incredibly fast, meaning-based semantic search far beyond simple keyword matching. 4. Storing. Finally, this processed, vectorized data is stored in a specialized vector database that's highly optimized for these kinds of similarity searches. It's now ready for the retriever to query lightning fast.
Okay, loading, chunking, vectorization, storing. Let's put that into a scenario. Say a team is setting up a retriever based on ingested knowledge articles. They realize a key field they need for grounding advice. Maybe the last validated data of the article isn't available to the AI, it's missing from the context. What's the correct technical step they need to take to fix this?
The solution here is you must update the search index to include that desired last validated date field. Remember, the search index acts as the gatekeeper. It controls precisely which fields from the source data are actually indexed and therefore made accessible to the retriever. Just trying to tweak the retriever configuration won't help if the index itself hasn't processed and made that specific field available for searching in the first place. You have to update the index definition.
Okay, strategy, deployment mechanics, data grounding, we've covered a lot of ground. Let's wrap this up with maybe 3 specific high-probability knowledge points. These feel like they come straight for those configuration or scenario-based questions you might see, dealing with the day-to-day reality of implementing Agentforce. First one, prompt templates. Scenario. Leadership wants an AI to help agents by populating a dynamic form field, say, the case description, with a concise summary generated by the LLM. However, there's a strict mandate for human in the loop. That means the agent must be able to review and edit the AI-generated text before the case is saved or submitted. Which specific prompt template type is designed for exactly this requirement?
Right. For that specific scenario, populating a field, but allowing human review the correct template type is field generation. This template type is purpose-built for using an LLM to generate content for a single dynamic form field. And crucially, the way it works is it injects that generated content into the field before the record is saved. This means the content sits there in an editable field, perfectly facilitating that human-in-the-loop review and edit process before final submission. You wouldn't use, say, sales email, which is for generating email bodies, or record summary, which usually provides a more static, read-only overview of a whole record. Neither allows for that critical in-field editing step.
Perfect. Okay, next. Permissions. Classic Salesforce stuff, but with an AI twist. An Agentforce service agent gets deployed, but the human agents start reporting that the AI can't interact with a brand new custom object. Let's call it product replacement off. The AI needs to be able to read and maybe create these replacement records. What's the fundamental change needed to fix this object visibility problem for the agent?
Yep. This comes down to fundamental Salesforce access control. If the Agentforce agent itself can't see or interact with that custom object, the necessary change is almost certainly to ensure the permission set assigned to the agent user grants the appropriate access, like read and create, to that product replacement AXA custom object. Remember, the agent user is the system context the AI runs under. Just like any other user performing actions via API or automation, its ability to see and touch records is dictated by its assigned profile or, more likely, permission sets. Things like flow permissions only control what the automation can do when invoked. They don't grant the underlying object visibility to the agent user itself.
Makes sense. Last one, conversation, context storage. So a customer is chatting with an Agentforce bot. Where does the actual transcript, the full back and forth of that conversation, get stored persistently? Which Salesforce object holds that detailed record?
The primary object that stores the complete, persistent conversation transcript between the customer and the agent, whether bot or human, is the messaging session object. This is crucial for audit trails, compliance, and any post-chat analysis or processing. And importantly, this messaging session record is also the key data source that features like Einstein work summaries used to generate those handy summaries for human agents when they take over a conversation. It also typically links directly to the related case record if one is created. #tag outro.
Okay, wow. We have definitely completed a demanding but hopefully extremely high-yield deep dive Absolutely critical stuff if you're aiming for success on that Agentforce specialist exam. So just to quickly recap the core pillars. Success with Agentforce deployment hinges entirely on a disciplined, rigorous DevOps approach. You need those 6 key steps to move the AI agent from just an idea to a governed, predictable operational reality.
And that governance, that predictability, it absolutely depends on mastering the metadata hierarchy. Remember the order. Auxiliary artifacts first, then prompts, then functions, then topics, and only then the modular planner bundle. Get that sequence wrong, and you're setting yourself up for failure. We also detailed how the Agentforce data library in Data Cloud automatically creates that essential trio, the data stream, the search index, and the retriever, to enable precise, reliable, RAID-based grounding for your AI.
Yeah, ultimately, managing Agentforce metadata with this kind of rigor isn't just a technical task. It's the only way you can successfully scale AI reliably in the enterprise. It's the agent's DNA, like you said. Get it right, and you ensure consistency, reliability, and faster feature releases.
Which brings us right back to that point of friction we highlighted earlier. Something for you, the listener, to really think about as you prepare for real-world deployments, not just the exam scenarios. We established that while we can deploy almost all the functional components of an agent, the prompts, functions, planners, using the metadata API and CI/CD, that initial foundational enabling of the core Agentforce features themselves, like turning on Einstein Copilot for the whole org, that often still requires a manual click in the setup UI, or maybe setting a specific org preference, enable Einstein GPT Copilot, for instance, that might bypass standard deployment automation. So the provocative thought is this. If your end goal is truly end-to-end automation for governance and consistency, how do you successfully track, manage, and audit these critical manual prerequisites within your automated pipeline? How do you guarantee they are correctly configured in every single environment before your automated deployment script even tries to run? Because sometimes it's that single forgotten checkbox, not the complex metadata package, that brings an otherwise flawless release crashing down. How do you automate the unautomatable parts?